Hi everyone! In this video I've got an interesting arithmetic sequence question. What makes this question interesting is we don't know how many terms there are, which is kind of backwards. Usually you know the number of terms and you're trying to work with that. So we know that it's 3 plus 7 plus 11 plus 15 plus some unknown number of terms, sums 406. So how are we going to figure out how many terms there are? I mean, without brute forcing it, right? Like we don't want to just, plug in all the numbers forever. This is a kind of an interesting question because it's going to turn out to be a quadratic, right? You guys all love quadratics. Well, they're back, this time from arithmetic sequences. Okay, so let's just, go through and figure out what we know. Our first term, of course, is going to be 3. Our difference, of course, you figured out by now, I'm sure, is plus 4. And our sum, we don't know how many terms there are, so the n we don't know, but our sum is 406. So there's some sort of SN formula that you can memorize. Maybe it's on your formula sheet that's sort of fancy. I only ever bothered memorizing this one because it's the one that was good enough for Gauss, and if it was good enough for Gauss, it's good enough for me. Anyway, so you got your first term, your last term, you average them, so add them together and divide by 2, and then multiply by your number of terms. And AN is going to be your first term. So A1 plus your difference applied n minus 1 times. So you got two A1s, and I guess for the purpose of this question, let's just start substituting our numbers as well in the same step. So our sum is 406, and we've got n we don't know. We're going to have two A1s, and the A1s are each 3. Plus our difference is 4, and we have n minus 1 of those differences. So let's distribute what we can, simplify what we can. So 2 times 3 is 6. The 4 goes across, we're going to have 4 n's, and then negative 4. Now these two, the negative 4 and the positive 6, leaves us with a positive 2 behind. So now we can, I guess let's distribute the half. So when we divide both of those things by 2, what do we get? So 406 is n times, 2 divided by 2 is 1, 4 divided by 2 is 2. And this is actually a quadratic. So on my right-hand side, if I distribute my n, I'm going to end up with 2n squared plus n. And the 406 we'll bring to the other side to make it negative 406. So that we can set it equal to 0, right? Because whenever you're solving a quadratic, you want it to be equal to 0 because of the 0 property. Okay, so looking at this looks like 406 looks like a pretty big number, but I don't think it'll be that crazy because there's like the invisible 1 there, right? So when you need to get a difference of 1, usually it's actually fairly easy to factor manually. We need to come up with two numbers that multiply to our product of double 406 is going to be 8, 12, and that's a negative product. And we need two numbers that sum positive 1. Okay, so since you need to sum positive 1, we know there are going to be two numbers that are 1 apart from each other. And just sort of thinking, broadly, 30 times 30 is 900. So we're going to be pretty close to 30 times 30. 29 times 30 isn't going to be low enough. Well, pull out a calculator and check, and sure enough, 28 and 29 give you that product, and we want it to be positive 1, so the 28 has to be negative. So then this is going to be, after you factor it, our two numbers. Now this is sort of where the video sort of goes off the rails a little bit because I don't know which type of factoring you learned. So I guess I'll do factoring by grouping because that's probably the most common one that is taught. It's not my favorite method, but that's the one I'll show because that's probably the one you know. But however you learned how to factor, if you don't like factoring by grouping, there's lots of ways of factoring. But by this point, you guys should know how to factor pretty well. Now 29 is going to go into this. We know this is 29 times something. Well, 29 times 28 was double that, so that's got to be a 14, right? Just sort of using our logic on that, the factors. We pulled the factor of 2 out, so it's got to be a 14 that's left, not a 28. And sure enough, we've got n minus 14. So we have 0 equals n minus 14 is one factor, and our other factor is 2n plus 29. And this one's going to give us a negative root, and so we know that it's not negative, right? You can't have a negative number of terms. That doesn't make any sense. So it's got to be the positive root, n equals 14 terms. All right, and as you can see, I've actually got another question lined up, which I will do in my next video.